everybody. Welcome to the live stream of our launch today. I am here, but today we're going to be doing the launch of Rocket Lab's Electron rocket, carrying 30 payloads, called Return to Sender. So the reason why they're calling it Return to Sender is because it is going to be carrying. It's going to be launching, and then when the stages separate, the first stage will come back, parachute down, and return to the center. This is the first time Rocket Lab's attempting that, so we're all crossing our fingers that it's going to work. So yeah, let's get started. I'm going to share my screen here, and we will share. So feel free to ask any questions you have in the chat. We will answer that towards the end. So yeah. So we're going to be talking about the Electron. So we'll start with let's start reading. The Electron is developed and launched by Rocket Lab. This will be its 16th mission, and so far it's only had one failure. The rest have been successes, so that's what we want to hear. This will be the first time they will attempt to catch the booster, and I'll show you a video of them doing that. The Electron is a two-stage rocket with an optional third stage in case the customer wants it. And on the first stage there are 9 engines, and on the second stage there is 1. Let's take a look at that video here. Okay, hopefully, let's see. I'm going to stop my share here. Let me just share my other screen with that video. Here. Okay, we're going to start here, then hopefully everything goes. I see your question. We'll be answering that. I'll be answering that after this video. Okay, so we'll be answering your questions in just a sec. Let me just pull this back up here. Here we go. Let's answer your questions here first. Do you know how long the Russian? It's been It's been 63 years now since the Russians launched their first satellite. How can they control where the stage will land, or do they have a general idea and have the boats nearby to go grab it? So what they're going to be doing is, it really depends on the company. This company, Rocket Lab, has a boat. They also have helicopters because Peter Beck, who's the founder and CEO, is really big on helicopters. So of course they had to include one. So they have the way that they're doing it. The way that they're doing it for this rocket launch is they have a steerable parachute, so they can steer the parachute, and then have the helicopter go catch it. For SpaceX, they ignite the engines, and they have a general idea, and the engines ignite, and you can control it by using the thrust weight and other stuff like that. So let's start talk about there are 30 payloads launched. So here they are being installed into the fairing, which there's a fairing there, and there is the payload. So let's talk a little bit about the upcoming rocket launches. We don't have that many that I can do. The next one that I can do is the Soyuz Falcon I-2, which will be launching November 28th at 8:33 p.m. Or that's what it's projected to be, although it's still 9 days away, so we are not 100% sure. I already answered questions. I just want to double. Oh, we've got a pushback. It's been pushed back. I want to see what everybody else is saying. It's gotten pushed back. I'm assuming we'll be launching a little bit later. So we are going to take a quick break here, and I will leave you with. Let me just share my screen here. I'm going to share my other screen. Sorry about doing it. Okay. So yeah, I'll leave you with Rocket Lab's logo here. We'll take a quick break, and we'll see you guys shortly. Goodbye. Oh, and yes, we have a question. Does it float? So it doesn't float. It's going to be caught by a helicopter, just like you saw in the video. So yeah, we're going to take a quick break here while I figure out what's going on, okay? And we'll be back soon. Hello, everybody. We're back here. We will continue. The launch is now expected for 9:20, which is in just under 35 minutes, and we're hoping that it will launch soon. So, thank you all for joining us here today. It's a real special day, real great launch for Electron when it returns to its sender. So, yeah. If you're just joining us, once again, you're watching the Space Daily's live coverage of the launch of Rocket Lab's Electron rocket, which is carrying 30 satellites, and it's named Return to Sender. So if you ever forget, just look right on down here. Got it scrolling right there. We are, so yeah, we're getting ready for launch here, and if you have any questions about the Electron, about space in general, please write it down in the comments. I'll be happy to answer them. And yeah, so the Electron, I already went through the slides. I don't want to go through it again, although I'll just give you a summary if you're just joining us. The Electron is a two-stage rocket, sometimes 3 stages, if the customer wants a kick stage. It has 9 engines on the first stage, 1 engine on the second stage, and if you do the third stage, it also has 1 engine. This is going to be their first attempt at reusing it, which is real special. SpaceX's first attempt at reusing it actually didn't go as planned, and it fell over. But you know, sometimes you gotta have failure in order to succeed. Hopefully they don't fail, because they've been through a lot more testing than SpaceX, although you know, there might be some failure, but it's going to launch. Then it's going to have MECO. The 2 stages will separate. The second stage will go onto orbit. The first stage will do a quick entry burn. It'll go through the atmosphere, and then a parachute will deploy. And parachute will deploy, and it's a steerable parachute, so it can steer itself. And a helicopter will be waiting there to catch the parachute and bring it on towards the ground, and we'll see what they do from there. So hopefully Rocket Lab will be going live soon. And yeah. So if you have any questions, once again, feel free to write it in the chat. Thank you all for joining us. Yeah. So the payload, one of the payloads is actually Boeing's is a satellite that Boeing made. It's going to try and test. I didn't just learned about this, but it's going to try and test. Trying to grab stuff from space and bringing it down. They're going to attempt re-entry on this one, I think. I'm not 100% sure, although I'm pretty sure that's what they're doing. And then if that goes well, then they're going to start doing that with some real space junk, and hopefully it'll reduce the amount of space junk in orbit and reduce crashes. So yeah. So we're about to. Oh, they're still waiting for Rocket Lab. Hopefully they'll start their stream soon. If not, then I think we're going to have to end it. But if you're just joining us, this is the live coverage of Electrons and Rocket Lab's return to sender. Now, something about Rocket Lab that I really like is that they name all their launches based off of like funny things. Like, it's just a test was their first one. The second one was like still testing, and now this one's return to sender. So yeah. Okay, it looks like we're getting ready. They're about to start here. I'm going to share my screen and pull that on up. Here we go. Okay. So, yeah, Rocket Lab was founded by Peter Beck. who started the company. I don't know when, somewhere in the 2010s. Somewhere around 2010, and it's been a successful company. It's launched 16 times, one of them being a failure, the rest of them being successful. And apparently that rocket launch live stream that I did yesterday, or not yesterday, on Monday, I think it was, it actually failed, and the payloads came tumbling down. It was due to a thrust issue. Whenever the computer said to go one way, it went the other way. So instead of going down, it went up, and then it ended up crashing back into the Earth, which is not good. And we're really sorry for all those who lost their payloads during that launch today. So we're still waiting for Rocket Lab, although I'm pretty sure we've got the time at 9:20. So yeah. If you have any questions, once again, feel free to put them in the chat. We're currently we're at T-minus 28 minutes. So yeah. Yeah. Okay, we're going to pause here. We're going to show the full screen of Rocket Labs, Rocket Lab over here, and then we will continue in just a couple seconds. See you guys. Almost ready for launch here.
Recovery effort does not include an attempt to catch the booster mid-air with a helicopter. That will come in future attempts once we've completed successful parachute re-entries. So, right now, our recovery team is ready and in position in a vessel in the Pacific Ocean, close to where we're expecting Electron's first stage to splash down at about 8.5 minutes or so after liftoff.
Okay, so apparently they are not. Apparently they're not catching the stage. They are actually. They're going to parachute it down to the water, I guess, which is different. This time, they're just going to master steering the parachute, I guess, this time. Then they'll move on to actually catching it. So yeah, let's listen to what Peter Beck has to say about this. That's Peter Beck.
Scale test where there's lots of energy and it's been super fun.
Okay, so it sounds like Peter Beck's happy about it and he can't wait.
Set out at Rocket Lab to try and recover the vehicle, primarily to increase production. And first, I didn't think it was feasible to do with a small launch vehicle, because if you look at all the traditional approaches, they're just not going to work. You don't have the propellant margins in a small launch vehicle. So we had to look at different approaches. And as we started to pull real data from real flights, it became obvious that there was an approach that could work. It was a little bit unconventional, and we started off down that path. So after separation, it will coast on up to apogee, do a flip, come in engines first, accelerates for a while as it comes in, and then decelerates, getting very hot in the process. Once we're down to about Mach 1.5, we'll activate a motor, which will deploy a drove parachute. That will slow it down further, and then when we're down to 2 or 3 kilometers altitude, we'll extract the main parachute, which is a big 18-meter ring sail, and that will slow us down to a fairly modest velocity of about 10 meters per second, where we'll take a splash in the ocean. A lot of it comes down to just the size and mass constraints that we're dealing with. Trying to package a whole load of extra equipment, motor, extra parachutes, reaction control system, gas bottles for that, and the additional electronics into a volume that's already very tightly filled with the second stage rocket engine and battery compartment. That was probably our biggest challenge. The most important thing that we're trying to achieve here is just to get the stage down to Earth in one piece, or as close to one piece as possible. So we won't be trying to scoop it out of the sky with a helicopter. We have demonstrated that we can do that, so I'm not too worried about that. The real challenge for us here is getting it through the wall, getting it under a parachute, getting it decelerated, and gently touching down into the ocean, where we'll go and pick it up with recovery vessels. Okay, the main parachute on the stage is a ring sail parachute. This is a design that NASA used way back at the dawn of the space age. Same design used for the Mercury and Gemini and Apollo spacecraft.
It's much easier to deploy, especially at high speeds, which means we don't need a complicated parachute system to get it out there. So that's why we've chosen ring sail parachute for now, as opposed to a kind of gliding parachute that we looked at previously.
It's kind of like a CSI scene we really start to peel back the onion and understand exactly what's happened. There's nothing like actually having a flight article that's returned to understand the margin here and the margin there, and which bits really worked well and which bits are just roasted up completely. If we get the stage back, we'll have a really good idea of how much work we've got ahead of us. Recovery for our customers is really about making sure that there's more launch opportunities available. If we can recover a stage, we can open up many more launch opportunities and create a much more flexible environment for our customers to pick and choose which flight they want to get on, ultimately try and lower the cost, and just make launch even that more prolific.
So that's what you want to hear. This is going to be the first time they're attempting it, but they're not going to catch it on a plane, sadly. They're just going to...
So as you heard Peter Beck mention there, our ultimate goal for this attempt is to fish an intact booster out of the ocean that we can transport back to our facilities to check out what we've got. Keep an eye out on our...
So basically this is a test at trying to reuse it, and then they're going to take a look at the booster and see what they can do with it, see how they can edit it, and make it so that they could deploy the parachute and catch it with a helicopter next time. So we're T-minus 12 minutes and 20 seconds until launch. So let's listen back in. Hopefully something good is happening at mission control.
GNC is go.
Beacon. Beacon is go.
Doing the go, no go poll.
T1. T1 is go. GC.
GC is go.
ELS.
This is good.
RSL.
You don't see anything.
Net.
Let me...
Let's go.
MM.
MM is go.
Recovery.
Recovery is go.
I think it's something on your end because I can
Executive.
see everything perfectly.
Executives go for launch and recovery.
Go no go sequence complete. We are at T-minus 11 minutes, 37 seconds and counting.
Okay, so everything's go, and
Terminal count starting at T-minus 10 minutes.
okay, terminal
This
count is in a minute and a half.
Hold procedure is in effect.
Jimmy, if you start to see anything, please write in the comments. If you can hear me too, I'm pretty sure it's on your end.
And there you have it. Our operators and launch director have confirmed Electron is primed and ready on the pad at Launch Complex 1.
Okay, 1 minute
Now to the
till
customers
terminal
aboard
countdown.
this special mission. The satellites for this launch span a range of operations from tech.
Okay, so yeah,
demonstrations
it's on
to
your
maritime
end, Jimmy.
surveillance, communications, and education, as well as a final special guest hitching a ride to space. Today's mission will launch the APSS-1 satellite from the Auckland Program for Space Systems from the University of Auckland here in New Zealand. This is a particularly special payload because it's New Zealand's first student-built satellite. APSS-1 is designed to measure electrical activity in the upper reaches of the Earth's atmosphere, right at the edge of space, a region known as the ionosphere. Because the ionosphere is ionized by solar and cosmic radiation and is affected by phenomena such as solar winds, it is uniquely reactive to the changing magnetic and electrical conditions.
So right now we're
That means
talking about the
affects radio and
payload. So.
GPS signals here on Earth, including television, internet, and
Okay,
telecommunications.
that's good. We
The
want
scientists are
to hear
also
that you're
curious
watching.
to what extent and how the ionosphere is affected by geophysical activity here on Earth, including whether the electrical disturbances that occur in the ionosphere might be correlated with earthquakes.
Okay,
More than
we're at
26
terminal
students
count.
have worked on this satellite across several years, so we're very proud to be delivering it to space today. To support innovative student projects like this one, Rocket Lab is providing the launch service to the Auckland Program for Space Systems at no cost.
Okay, that's great. So
Next on the list is the drag racer payload from US company Tricept, which is designed to test new tether technologies that could accelerate spacecraft re-entry and reduce orbital debris at the conclusion of space missions. Tricept's payload includes two 6U smallsats, one with a tether drag device measuring 70 meters long and the other without. Next up, we're welcoming a return customer back on board Electron, following the first successful deployment with Rocket Lab in August of 2019, French company Unseen Labs. This launch includes two of their satellites to grow their maritime surveillance constellation. Both of these small sats independently and precisely locate and fingerprint radio frequency emitters all around the globe, day or night in any weather conditions, and without requiring any special embarked tracking device.
That's right, and 24 of the satellites on board today's mission include the latest quarter-use Space Bee satellites from Swarm. These Space Bees are designed to provide affordable satellite communication services to IoT devices in remote regions around the world.
Okay, that's
And
good.
finally, fans of the game Half-Life will recognize our very special guest on this mission from Valve co-founder Gabe Newell. I'd like to introduce you to Noam Chomsky. That's right, we are launching a garden gnome to space, or to be more precise, a mass simulator in the shape of a garden gnome. This little guy right here is a replica of the one sitting inside Electron's fairing, which is about to head to space. Manufactured with support from the Weta Workshop, this tiny astronaut will finally complete his achievement for real. Because we have a no gnome left behind policy here at Rocket Lab, Mr. Chomsky will remain attached to the kick stage and deorbit with it as it falls back to Earth.
Not only does this mission serve as a tribute to the innovation and creativity of gamers worldwide, but Gabe Newell is personally donating $1 to the Pediatric Intensive Care Unit at Starship's Children's Hospital for every person who watches the launch with us today. So thank you so much for tuning in. And thank you to all of our customers for choosing to ride on Electron. We couldn't ask for better mission partners, and we're proud to be working with you all.
So just heard a siren at the launch pad. That siren signaling for everybody to get away since they're T-minus 7.5 minutes. Any questions, feel free to write in the chat. I'll be happy to answer them right here, right now. Okay, so we're T-minus 7 minutes now. This beautiful day in New Zealand. Oh, why did I get pushed back later? We are currently not sure. We think it's from. We think it's from.
Sequence 51, AFTS enabled for flight.
Well, I don't know why it got pushed back, sadly. But yeah. How much time till launch? We are T-minus 6.5 minutes.
AFTS is green and enabled for flight.
Okay. T-minus 6 minutes and 20 seconds.
The 18-meter tall Electron is made of 2 stages to get to orbit and a 3rd stage for precise deployment of satellites on board. Electron's 9 Rutherford engines at the bottom of the 1st stage do the heavy lifting for space before the 2nd stage separates to carry on the mission. The 2nd stage is powered by a single electrically pumped Rutherford to get to orbit before Electron's kick stage takes over and carries out the final leg of the journey to deliver the satellites on board to their specific destinations. Once stage separation occurs, approximately 2.5 minutes into the mission, Electron's 1st stage booster, which you can see on your screen there, will begin its descent back to Earth, and it's this part of the rocket we'll be attempting to recover on the mission today.
To support this mission's recovery attempt, we've added some extra hardware and components to Electron's 1st stage. Here to tell us more about what's been added to Electron is Dominic Fu, a familiar face and integration technician whose team assembled the rocket and the recovery hardware. He joins us now from Rocket Lab's main production facility. Dom, what can you tell us about the differences on the 1st stage for today's mission?
Hey Max, that's right. The 1st stage on Electron is a little different on this mission, but it's not just a paint job that's new. I'm standing on the factory floor here at one of our production complexes, and behind me there are about 7 Electron rockets, all lined up for missions later this year and early next year. Right here is where the 1st stage for today's mission was fitted with recovery systems that will hopefully enable us to bring the stage back under our parachute today. Now, approximately 2.5 minutes after liftoff, at an altitude of around 80 kilometers, Electron's 1st and 2nd stages will separate. Electron's 2nd stage will continue to orbit, where the kick stage will separate and deploy the satellites. So up until now, we're following a standard mission profile, but next is where it gets interesting for recovery. With engines now shut down on Electron's 1st stage, a reaction control system will reorient the stage 180 degrees to place it on an ideal angle for re-entry, designed to enable it to survive the incredible heat and pressure known as the wall during its descent back to Earth. Now on the recovery booster, the RCS thrusters are located near the top of the vehicle, highlighted on your screen. When Electron decelerates below Mach 2, a drogue parachute will be deployed to increase drag to stabilize the 1st stage as it descends. In the final kilometers of descent, a large main parachute will be deployed to further slow the stage and enable the controlled splashdown. Our team on the recovery vessel will rendezvous with the stage after splashdown and retrieve it for transport back to this production complex for inspection. When we get the stage back to the factory, we'll inspect every inch and use that knowledge to inform our next recovery effort. It's going to be such an amazing mission to watch. I'm just going to wrap this up right now. I'm going to join everybody else at Mission Control. Back to you, Max and Ari.
Thanks very much, Dom. The recovery team might be leading the program to bring back an Electron, but almost every team across the business has been involved in getting us to this point. So it's exciting to be just minutes away from liftoff for this very special mission. A quick reminder that we will have live video of the beginning of the recovery process. We're expecting the feed will cut out as Electron goes through the wall and eventually drops out of telemetry range. We'll be sharing photos of the recovery effort on the water as soon as they're available. So, with just 2.5 minutes left in the count, we're going to hand you over now to listen in on comms from Mission Control for the final minutes until launch.
All stations, LD on mission cord. We are go for auto sequence start. T-minus 2 minutes. LD is go for launch.
Oh, whoopsie. Some reason. Okay, what time is it? It's 3:18. I'm in New Zealand, and for some reason I have to get back quickly since. For some reason, crimp tab.
AV bets are on internal power.
Okay. T-minus 1 minute and 50 seconds till launch.
It's fully on internal power.
It's actually current. Okay, terminal countdown. Okay, I'm gonna go to full screen so that you guys can enjoy.
Launch loader is complete. System is in recirculation. Anti-gas ring disabled.
Stage 1 and Stage 2 tanks are pressed.
High flow engine purge is enabled. Deluge is activated.
T-minus 20 seconds and counting.
Almost at liftoff. 10.
T-minus 10.
9.
8.
8. 7. 6.
6.
5. 4. 3. There you see the water. We got a liftoff. Oh, funny. They're putting like achievement unlocked. Haha. There we go. There goes Electron. Got it. Its first reusable launch. Go Rocket Lab. Go Electron. There we go. Successful launch here in New Zealand.
Stage 1 propulsion is nominal.
Stage 1 propulsion is nominal. We want to hear that at every rocket launch, at every one that's going to be successful. We're almost at max Q, maximum aerodynamic pressure, when
Entering stage 1 burnout detect mode.
okay, burnout detect mode.
And we have liftoff of Electron from Rocket Lab Launch Complex 1. We're just 50 seconds into flight and heard the call out on comms there that the mission is continuing nominally. So Electron will approach max Q along its trajectory, otherwise known as maximum aerodynamic pressure.
Okay, we should be having max Q any second now.
Approaching maximum dynamic pressure.
There we go, approaching max Q.
Past maximum dynamic pressure.
Okay, we're going to have throttle up right after the maximum aerodynamic pressure has been passed, which is
And there goes the call from our operator on console. Electron has cleared max Q. Propulsion is continuing to look good on the path to orbit.
Okay, next up is staging, then fairing separation. Those are our next two events. Although staging consists of MECO stage separation and second stage ignition, a whole bunch has to be done before it is finally done.
Coming up next in the mission timeline is main engine cutoff, also known as MECO, as Electron's Rutherford engines power down so that the first and second stages of the vehicle can separate cleanly.
And right over
Following
here, you
that,
can
the
see
vacuum
the
optimized engine on the
thrusters
second stage
that will help it
to carry the satellites on
guide
board
itself.
further into space. While Electron's booster will begin to fall back to Earth, marking the start of our recovery attempt. The team on the recovery vessel will now be furiously checking its return telemetry.
Okay, everything's looking good here. About to have MECO
MECO confirmed.
Staging.
stage separation there.
Stage ignition.
There we go.
Recovery telemetry nominal.
Flight analyst, recovery, LDM mission core, execute sequence 53, stage 1 recovery operations.
Confusing landing zone.
MECO is confirmed, and so too is the startup of the second stage Rutherford engine. With the separation of stage 1 and 2 complete, we'll try and stick with both views as long as we have them. The trajectories are looking good so far while we're awaiting fairing separation.
Fairing separation confirmed. Let's see if we have. Oh, there's visual confirmation. There's a gnome that they were talking
There goes the
about.
fairing, and welcome to space, Mr. Noam Chomsky.
I'm really happy that they're launching a gnome to space. It's really.
Stage 2 propulsion is nominal.
Stage 2 propulsion is nominal. We are T plus 3 minutes and 40 seconds. Our gnome is looking good up there. And no, we're gonna be, yes, we will be able to see the up to parachute deployment. That will be it, since I don't know why, but they just.
If you're just tuning into the broadcast for our 16th Electron launch,
It's not like they said broadcast, not broadcast.
in New Zealand, and have had a successful MECO, stage separation, and stage 2 ignition. Electron's second stage burn is in progress as we hit 4 minutes and 17 seconds into flight.
Okay, everything's looking good. The successful launch right out of New Zealand. Successful stage separation, MECO, and second stage ignition. Successful fairing separation, and soon we're going to get ready for battery jettison, where it will do battery hot swap, where we'll change batteries. And then get rid of the other one so that it has less weight.
A couple of months ago, some of you may remember we conducted the maiden flight of our Photon satellite, which we called First Light, during our 14th launch. The kick stage, which you can see Mr. Noam Chomsky mounted to here, forms the basis of our Photon satellites. By offering launches and satellites as a bundled service, we make it easier for small satellite operators to get to space, removing the need for them to source satellite, launch, and ground stations separately.
Okay, there we go. Approaching battery jettison and battery hot swap.
Stage 2 guidance still nominal. 200 seconds remaining.
Just a quick update for you all here. Electron's second stage burn continues nominally at a velocity of 14,000 kilometers per hour and an altitude of 190 kilometers. It looks like we've still got visual of stage reentry as well, and it feels good to be back in space.
Oh, yeah. So apparently for every view that's happening on Rocket Lab's Electron on this live stream that we're showing right
6
here,
minutes and 8 seconds into flight.
money will be given to
Second stage
charity.
and first stage booster re-entry are looking stable. Next up will be battery hot swap to continue supplying power to the second stage engine and systems. Let's listen in for that call.
EFT is saved.
Okay, I think we lost connection on the second stage and the first stage. Let me just double check. Never mind, I think the second stage is actually working. Just looks very frozen to me, although I guess not.
Stage 2 propulsion is nominal.
There we go.
Stage 1 re-entry.
Okay.
We've had battery hot swap confirmation, and we're about a minute and a half away from when we expect stage 1's drogue chute to deploy. The ride is going to get a little bumpy on the way back down, with the booster reaching several times the speed of sound on its fall back to Earth.
Okay, that's what we want to hear there. Getting ready for drogue chute deployment. A
reminder that we'll stick with the video feed as long as we can, but we do expect to lose it soon.
Okay, so they are expecting to lose it, but hopefully we don't, because this is one exciting launch, one that you want to see and hear about.
And as expected, it looks like we've lost video connection to Electron's booster there. We should
Well,
expect the first stage's main parachute to deploy at about 8 minutes and 44 seconds into the mission. If we get that confirmation while we're still on the air, we'll be sure to share it with you. Otherwise, check in on our social media channels for further updates when we end the broadcast. Now let's listen in for the call while we wait for stage 2 separation.
Okay. So when they end, we're probably going to end, and they're probably going to end pretty soon. So when they end, we'll end. Once again, thank you all for joining us. Sorry about the pushback earlier, but this is Gnome-tastic. According to our gnome, who is enjoying his ride to space, and every gnome will return to Earth. He will probably...
Seeker confirmed.
Nominal transfer orbit.
Seiko confirmed. We're getting ready for kick stage separation. Gnome alone. Achieve. I love how they're doing that achievement unlocked.
Right. From the team in mission control, the engine on Electron's second stage has shut down and the kick stage has separated. So Noam Chomsky finally gets his day in space.
Noam Chomsky.
In approximately 45 minutes or so, the payloads will be deployed to their precise locations using our innovative kick stage. So here's a quick rundown of how this additional stage works.
Okay, let's watch that and see what they have to say about their kick stage. Then we shall wrap up.
Electron's second stage takes us to an elliptical orbit where the kick stage then separates. From here, the 3D printed Curie engine on Electron ignites to propel the stage and its payloads to a circular orbit for deployment. Using a cold gas reaction control system, or RCS, the kick stage accurately points itself to deploy each satellite to a precise and individual orbit, even on rideshare missions with multiple satellites like this one. Once the satellites are deployed, the Curie engine reignites, propelling the kick stage to a lower orbit, where it will be dragged into the Earth's atmosphere faster, leaving behind no space junk in orbit.
So that's what you want. We're probably going to wrap up here. I'm going to stop the share. Thank you all for joining us today. I'm really sorry that it got pushed back. If we have any more news, anything that you want to see, anything that you want to hear, and I'll show you guys the landing if I find it on our next live stream. So see you guys later. Once again, I'm Gabriel. That'll do it for me in Space Daily. Goodbye. I'll give you guys 30 seconds to get out of here. So see you.